Well, hello, everyone. My name is Matthew McCabe. I'm a professor of remote sensing and water security at KAUST in Saudi Arabia. It's a great pleasure to present my work to you today, albeit virtually. I couldn't be there in person. I'm actually recording this from Australia, so the time zones are a little bit out of skew. But before I start, I'd really like to thank the organisers of this amazing conference, first for the invitation, but also to pay acknowledgement to the Prince Sultan bin Abdulaziz International Prize for Water, who I'm representing as a recent awardee. Now, the work I'm going to explore today really operates at the intersection of water and food security. And I'm going to investigate the role that some new advances in Earth observation are providing and how we can use those to address some of the water resource management and protection challenges that are facing arid zones in particular. I'm going to be drawing from some examples from Saudi Arabia as well to populate my talk. Now, as a bit of background, we're all aware of the projections by 2050, another 2 billion people populating the Earth, most of whom are going to be born into the developing world, and those particular environments are made even more challenging, I suppose, due to the complicating impacts of climate change. So in terms of water resources, well, the influences of this changing population as well as climate change are going to be felt through the impacts and variations that the water cycle presents. Now, the estimates on how much food we're going to need to produce to support this extra 2 billion people vary quite a bit, but that's only part of the problem. We're already dealing with food and water security issues today, so it's not something that we can put off for another 20 years to find a solution. This is a clear and present danger to the structure and development of society. So the work that this conference is focusing on, the work that my own team is undertaking, has particular relevance to these global challenges. Now, in the face of climate changes and other adverse impacts, we can understand that these particular challenges related to food and water security are only going to get worse. And to put it very simply, we're going to have to learn to do more with less. And that's quite a different concept to how we currently grow our food and many other activities within the environment interface, which is basically just doing more with more. And we clearly can't do that any further. We've exhausted water resources, we've exhausted natural resources. We're having an indelible impact on the environment. This is something where we need to reverse the trend. And from my perspective, tapping and mining new information sources is going to be key. And these ideas of new information and bringing that to bear are really at the heart of this concept of sustainable intensification. So even though the broad question is how we're going to grow food is a major area of importance, and the security and sustainability of water supplies is obviously going to be a key part of that answer. Now, mapping global changes to freshwater availability has really been enabled over the last several decades by some dramatic advances in Earth observation, some of which I'm going to talk about in the coming slides, and one particular technology in particular. Now, this slide here provides a bit of an overview of both climate and anthropogenic impacts on freshwater availability, which is obviously a central variable for water security. And one of the trends that you can see emerging from these types of analysis, and I'm going to show some closer to home trends that bring that message to bear even more, is the strong overlap between irrigated lands and groundwater depletion. And the basic message here is we're using our groundwater resources faster than they can be replenished, which obviously has some major implications for food security going forward into the future. Now, that's especially important when you consider that irrigated lands, while they only make up around 20% of all farmlands, they produce more than 40% of our food. So it's a really outsized impact. And when we think about developing countries, where we talked about the next 2 billion people populating, irrigated agriculture really provides a strong lever on food security. So understanding these systems and managing the water security of them is obviously of paramount importance. And finding approaches to better manage that nexus of food and water is obviously critically important. So this is something that my group at CAUS has been exploring for the last 10 years that I've been there, and actually before when I was at other institutions. And it's really about how we can track water cycle and how it's being used through the hydrological system. Particularly, the question we're been focusing on is, can we quantify the water use in agriculture and therefore imply or infer the amount of water that's being extracted from our aquifers? Now, you think that'd be a fairly simple question to address in the sort of dryland systems that we operate in, but it's not. It's very difficult. And despite its critical importance, we really still don't know how much water is being used in food production or how much is being extracted by groundwater. So how we best model and model these components is a really important research question. I'm sure it's being addressed at the conference. Now, I want to really highlight that this is not just a problem for Saudi Arabia or the Middle East. This is a global problem, particularly in dryland, arid environments. So again, the focus of these types of questions for this conference is of critical importance. Now, for a sector that employs 1.3 billion people and represents a $2.4 trillion industry, the agriculture sector really still remains very much stuck in the dark ages. Our entire food and water system is really ripe for disruption. We need a digital transformation. And what we really need is local level knowledge delivered at the planetary scale. And that's really the kind of motivation that's driving a lot of my work. And we have a rich vein of information resources to choose from, driven in particular by Earth observation technologies. And I'm just giving you a little snapshot of some of the current and future missions that are planned by one space agency in particular. But when you put those together with opportunities from NASA, from the US, from within Europe, beyond, and other countries, it's a real golden age of Earth observation. We really need to identify how we can harness this technology, how we can harness the information being produced from these platforms to better understand the water cycle and the implications for food security. So with that long history of Earth observation, which is actually now stretching back more than 50 years in the case of the Landsat program, we've got this incredible perspective to both see changes in the past, but also monitor what is happening now. And that's a core function of the research that we're doing at CAUS. And these two videos give some really local examples of the impact of food security efforts in Saudi Arabia. And basically one of the questions that I've been exploring is what is the subsequent impact on water availability. So these are the two local aquifers up in Al Juf in the north and Wadi Adwasa down in the south. And you can see the dramatic expansion of irrigated agriculture that's occurred over the last several decades. But what is the consequent impact of that on water availability and water security? So as part of our work at CAUS, we've been collaborating with the Ministry of Environment, Water and Agriculture to both map this change and then put values to the volumes of water being used to grow food. And while there's a lot of engineering and science that goes into this, it's a whole other talk. We're fundamentally just undertaking a water account. We're trying to balance the budget of inflows and outflows to really understand how much bad credit, if you want to put it in economic terms, how much bad credit we're accumulating. Because clearly we're using more, we're taking more out than is being put into the system. But with that capacity to see back in time that Earth observation systems give you, that retrospective analysis, you can actually start to monitor changes and also assess the impacts, wherever they might come from, on agricultural production. And here you can see some real change happening on the ground, which is actually in response to government efforts to reduce water consumption. In this case, by banning the growth of fodder crops such as alfalfa and grasses. And you can start to see some areas that fields have either been abandoned, or in some cases, they've shifted from center pivot to orchard plantation, growing olives, fruits, and other tree crops. So just having this information is hugely valuable, not just for managing food and water resources, but for also understanding the effectiveness of policies that are being implemented to reduce water use. Now, the ultimate goal here is local information at the planetary scale. I talked about that before. Basically to measure and understand every field, everywhere, all the time. That's the mantra that we operate within our group. but we're still quite away from that. Now, there's a couple of reasons for that. I'm going to talk about them because when I first started in this area, I was really surprised by how much we didn't know about agricultural systems. For something as simple as the number of fields in a country, you would think that would be a statistic that would be readily available. Well, it's not. It's actually really hard to find. And it's not because the information is not there. It's just that it's not there in a ready format. You can sample these images, you can see all the fields, but getting from fields and tracking the dynamics through time, understanding what's growing on the ground, understanding what farmers might be growing into the future, these are variables that we need to know desperately, but which we don't normally collect. And if you want to make any fundamental progress in food or water security, that's information that you have to have. It's as simple as the old business maxim that you cannot manage what you do not measure. So part of our work at KAUST is really trying to measure all of these variables related to food and water security so that we can actually better manage the aquifer system. And we're becoming, with the advances that we're seeing in Earth observation as a field in general, becoming data rich, but we're still information poor. So the real challenge now is to turn that data into knowledge, to turn it into useful information. Now, a few years ago, I wrote a kind of a forward-looking synthesis to understand what are the potential technologies that may reshape the field of Earth observation over the next 5 to 10 years. And I'm not going to go into that. Here's the paper. You can have a look at it if you want to spend some time on it. But one aspect that we're really been exploring is this concept of CubeSats and the way that it's reshaped how we can actually view the Earth. Now, for those who aren't immediately familiar with CubeSats, I'm going to present a slide very shortly to show you, but it really is a paradigm change in how satellite space technologies are launched from government agencies. Most governments will launch a single $1 billion satellite, and it will take 10 years or more for it to go from concept through to reality. Well, the CubeSats kind of upend that equation. And now the other aspect I didn't mention with traditional satellite approaches is a big constraint. So whenever you're using satellite data from ESA or NASA, you always have to make a choice between how well you can see something and how often. What I mean by that is you can see something in really great detail occasionally, or you can choose to see it in poor detail, so from a geostationary satellite, for instance, regularly. But you can't have both. You can't have high resolution all the time. So that's where CubeSats have come into play. In the last few years, we've really seen a revolution in how we monitor the Earth system. So instead of launching that single $1 billion satellite, you launch many. You launch 100, a constellation of smaller, cheaper, shoebox-sized systems. So these are small, replaceable satellites that you may put up every few years that are really providing entirely new insights and offering imagery that can be used to map and monitor water use. And that's something my team has really been at the forefront of transforming, turning that data into useful and usable information, working with companies like Planet to translate that data into actionable intelligence. Now, I'm going to give you a few examples of how we've been doing that. This is one where we've been tracking the greening up phase of a crop every day, something that you just could never do before at the resolution of the within field scale. And here we're just trying to look for any problems or issues that might be occurring in the field before the farmer might even know about it. Now, apart from being able to resolve the fine scale detail needed to inform on-field decisions, it's got that temporal resolution that otherwise you would completely miss. If you were using Landsat or even Sentinel, you would completely miss some of these transitions. Now, with that information, you can actually start to develop other approaches. And this is where we look at leaf area index in this case. We're tracking leaf area index, providing new insights into crop health and condition. Now, the other aspect here is that not only can you track the crop health and condition, you can start to develop more insight into field productivity, field behavior. If you know the leaf area index, if you know some meteorology, you can start to get insights into crop water use. And this is something that we've been spending quite a bit of time on. Here's an example from a field or a collection of fields not too far from where you're located, actually in Rio. This is in Ahaj. Now, what we've been doing is using some remote sensing approaches to really advance the field of high-resolution crop water use estimation. This, what you're seeing here is actually the highest resolution estimates of crop water use ever retrieved from space before, 3 meter and daily. Now, that has implications not just for agricultural water management, but water monitoring. Being able to look at licensing and compliance, being able to look at issues in the field, whether there's irrigation breakdowns or problems, being able to look at crop development as it responds to these soil changes or a breakdown in irrigation. And then these types of data are really absolutely key to closing what we call the yield gap, particularly in developing countries where the challenge is most pertinent. That yield gap being what you could produce in most ideal circumstances with what you generally do get when your inputs, such as fertilizer and water and other nutrients, are not at their optimal rate. So with that information, you can start to move towards that ultimate goal that I mentioned before, the idea, the concept of every field, everywhere, all the time, not just in Saudi Arabia, but beyond. And that's something that we're doing at CAUS now. We're building a platform to do this nationally, where we can identify any individual field, look at the health and condition of that field, look at the water use in near real time and back through time, but also trying to expand that globally. It's a quite a big data challenge. It's not a simple, straightforward task, but we're combining CubeSats, we're combining newer meteorological advances, we're combining big data analysis platforms like Google Earth Engine to bring all that information together and help us deliver innovative data for water management and protection, not just at a farm level or a national level, but globally. Now, obviously, the ultimate goal here is local information at the planetary scale. That's why I sort of highlighted the importance and impact of the scale of these remote sensing data. 3 meters every day. Well, what we can actually get in the next year or two is sub-daily retrievals, which are really going to revolutionize again. Now, this is my final slide, or near final slide, so I wanted to give a bit of a recap. I guess when I first started in this area, many decades ago, I was really surprised by how much we didn't know about our agricultural systems. Given the absolute critical importance that food security, water security play, there's so much we don't know. Now, something as simple as the number of fields, that was really hard to find, and it's still hard to find, not just in Saudi Arabia, but in any country. Now, if we are going to change this paradigm, we need to harness these information resources. We need to bring them to bear, to combine them with remote sensing approaches and cloud scale architecture, to then give that information not just to governments, but to the farmers who actually need it. And I go back to that original point. You can't manage what you do not measure. And we are at the cusp of being able to provide those tools at multiple scales, looking back in time, but also looking forward into the future. With that, again, my apologies for not being able to attend. I hope to make it to the next one. This is an incredibly important conference. I'm enlightened by the fact that it's right in the middle of so much activity that's happening within the kingdom and beyond. I look forward to answering any questions. Please get in contact with me if any of this work is of interest. And thank you again to the organisers for the invitation. Best wishes.